Hello everyone, this is Matt with Zanger. Welcome back to our AP Calculus series. In Unit 1, we learn about limits and continuity. Now we are moving into Unit 2, differentiation. In this unit, we will cover three main topics. First, we will introduce the derivative, which is the main idea of this unit. Then, we will talk about differentiability and continuity and how they're connected. Finally, we will learn the basic differentiation rules, which help us find derivatives faster. And in today's video, we will go over 2.1 derivative. Let's start with the secant line. A secant line passes through 2 points on the curve. In this graph, the 2 points are C, FC, and C plus delta x, F, C plus delta x. The slope of this secant line is found using the slope formula, changing y over changing x. This is also called the difference quotient, because it compares how much the function changes over an interval. Let's compare that with a tangent line. A tangent line touches a curve at one specific point and shows the direction of the curve at the point. On a circle, the tangent line touches the circle at exact one point. But for general curves, the tangent lines means the line that best matches the curve's direction at the point. This idea is important because the derivative is the slope of this tangent line. So how can we get from a secant line to a tangent line? At first, the secant line uses 2 points on the curve, but as delta x gets smaller and smaller, the second point moves closer to the first point. As delta x approaches 0, the secant line becomes closer and closer to the tangent line, so the tangent line slope is really the limit of the secant line slope. We write this idea more formally. The slope of the curve at point P, x0, fx0 is defined as limit. The slope m is the limit as h approaches 0 of f of x0 plus h minus f of x0 over h. This formula is the limit of the difference quotient. It gives the instantaneous rate of change of a function at x. So when this limit exists, the derivative tells us the slope of the tangent line at that point. Here we have average rate of change and instantaneous rate of change. On the left, the secant line goes through 2 points. Its slope is delta y over delta x. This is the average rate of change. On the right, the point Q moves closer to P. The distance between them is h. As h approaches 0, the secant line approaches the tangent line. So the instantaneous rate of change is the slope at one exact point. This is what the derivative measures. Average rate of change, secant line slope, instantaneous rate of change, tangent line slope. Definition of the derivative. The derivative of f at x is f prime of x equals the limit as delta x approaches 0 of f of the x plus delta x minus fx, all divided by delta x. This is the same idea as before. The expression inside the limit is the average rate of change. After taking the limit, it becomes the instantaneous rate of change. So f prime x means the slope of the tangent line to y equal fx at x. The derivative only exists when the limit exists. There are several ways to write a derivative. F prime of x, dy dx, or the derivative of y with respect to x, and takes the derivative of fx with respect to x. All of these represent the same idea, the rate of change of the function. The notation dy over dx reminds us that the derivative is the limit of delta y over delta x, meaning the changing y divided by the changing x as delta x approaches 0. Sometimes we estimate the derivative instead of finding it exactly. F prime of a plus b over 2 equal to fb minus fa over b minus a. The right side is the slope between 2 points, a and b, so it is a secant slope. This means a slope of a secant line can approximate the derivative near the midpoint. The closer of the 2 points are, the better the approximation usually is. To summarize, f prime x0 can mean several things. It is the slope of y equal to fx at x equal to x0. It is the slope of the tangent line at x equal to x0. It is the instantaneous rate of change of fx with respect to x. And it is the limit of the difference quotient. The limit as h approaches 0 of f of x0 plus h minus f of x0, all divided by h. And that's everything for introduction of derivative. Thank you for watching.